And we're back. We are COMP305. That's Game Programming 1 at Centennial in the fall 2017 semester. And we are week 4, part 2 of our broadcast. We're still talking about MailPilot, but we're working on collisions. So how do I do collision detection? Well, there's some, math. There's some ways of doing it there's two ways. We talk about collision detection. We talk about broad phase and narrow phase. Have you guys heard about this? Let's talk about broad phase first. So imagine I have two objects on my scene, right? Like I want to collide with this thing here, right? So here's my island, and I have my plane. They're really far away from each other. Should I start checking for collisions right now? Really, really far away, right? There's a couple of theories here. You do broad phase collisions when this comes closer. So when this comes to a certain point, I should start checking for collisions. So broad phase means check to see, let's say, when I'm really far away or when it doesn't make sense. For example, if my bounding box, if I define a bounding box around an object, right, that's quite large, right, and it's a complex object inside. Like for example, my island, right, and I want to pull this into these objects into fireworks for a second. Okay, so I'm just going to drag out fireworks because I want to show you what I'm talking about. Okay. Now this is general theory. Okay, and there's different ways of doing collisions. One of them is called axis-aligned bounding box. Okay, axis-aligned bounding box, right? Where I kind of just kind of look at the pixels from one bounding box to the other, and I can detect whether I've got a collision, right? So axis-aligned bounding box is one. And the other way of doing it is through something called, a little bit more complex than this, all right, called separated axis theorem. Okay, so we're going to look at these couple of things. Now, separated axis theorem is crazy. If you want to do simulations, great. Playing games, forget it, unless it's something really complex, right? But there's a couple of ways of doing this. And the third way, which is the simplest way for 2D, especially 2D from a saving grace perspective, is distance. How far away is my object? Okay, so let's look at it in terms of, I brought this up because I want to look at assets. Let's look at our sprites. And I want to bring up my island sprite. Here's my island sprite. And I want to bring up my ocean sprite just to give you an idea of how this looks. Here's my ocean sprite. Okay. And I want to take my island. Here's just in the program here and put it on my ocean so you can see it. Let's put it down where it should be, somewhere down here, let's say. And let's grab my plane. So I've got actual object sizes, right? There's my plane. And I'm going to cut it and put it on my ocean and drag it in there. And then let's zoom in, right? Okay, so here's my plane. And you can see the little line. This is kind of a bounding box for the sprite. Here's the bounding box for the ocean or the island, right? Okay, if I look at both bounding boxes, if I highlight both, is there a collision? If I check bounding boxes from left to right, is there a collision? Or do they overlap? That's what the axis-aligned bounding boxes algorithm do, right? So it's called ADB Collision. You guys should know that, axis-aligned bounding box. And if you want to know more about this, I'm not going to go into too much detail, but if you want to know about AABB collision, collision detection, there's two ways: the collision detection and then collision response, right? AABB, it's literally axis-aligned bounding box. They actually don't give a good definition here. They've got this idea here where you have two boxes. You can't see it, but more or less you have two boxes, and when they cross over, right, then you have a collision. This would be a collision idea, right? If that makes any sense, right? Now, if I look at mine, do you see any kind of overlap? Okay, cool. So if I have, what about now? If I take this box here and I overlap it here, is that overlapping? All right. How about this? Is there a visual collision? So there's a calculation. We made a calculation to say that these bounding boxes are overlapping. So yeah, there's a collision from a overlapping bounding box perspective, right? But for me to check the overlapping bounding box, what I got to check is this. Is my other rectangle, I got to check that both rectangles from the left margin and the right margin are overlapping. And I've got to do 4 checks. I've got to check the top left corner, the top right corner, the bottom left corner, and the bottom right corner. And any one of those, because it can overlap this way, right? It can overlap, oops. It can overlap this way, right? It can overlap, oops, over here, right? And it can overlap over here. So I can check any one of these corners, or even on the sides and the tops, right? Where there could be some kind of overlap with one bounding box overlapping the other. So at least, if I'm not wrong, at least 2 of those must be true, right? Top right and bottom right. It's got to be between those 2, right? In order for this bounding box to check. The right thing to do is check all of them to make sure that it's, it's greater than, it's going to be greater than the minimum value of this bounding box. So the minimum value would be the top left corner, right? So it's greater than this from an X perspective, right? So at going this way, greater than this, right? And less than, I also have to check that it's less than the right side, right? Plus the offset, how offset it is from my screen. So I got to check not only where it is in the actual object, but where it is physically on my screen. So I got to know where it is. I got to offset it, right? And I got to check between the left side and the right, and the top and the bottom. So there's 4 checks I got to do, plus offsetting each one of those things with where the position of my object is. Great. But for 2D, right? If it was 3D, it'd be okay, because then I'd have 3 coordinate in a 3 coordinate space, 3 space. I have an object in 3D, and that makes sense because it's kind of okay to calculate that, especially for broad face collisions. So broad face collisions, if I have a big bounding box, that's okay. What about narrow face? Narrow face collisions where they really come close, right? And I can see that there's no visual collision here. Now here, because I'm using an island and a plane, you really can't see, you won't be able to see it. It's actually using an axis line bounding box, okay, because they're kind of squarish, right? But what if, let's bring in the other one. What if you have this cloud object? So the cloud object is differently shaped, and I picked this for right here. And let's just get rid of this thing for a second. So we don't care about this one. We'll just get rid of it. Let's just delete it here. All right, so here's my cloud, and do I have a visual collision there? But is it a collision? It is. You can see that it is a collision, right? Because I would calculate this as if I use axis line bounding box on this particular corner, it would look like my plane is not colliding, right? But I'm actually colliding. Why? Because the bounding box of my sprite is the component. Now I can change the size of my bounding box, my check region, if you will, right? So I can make it smaller so that it is more closely surrounding my object, right? But then I'm going to have a little bit of overlap, right? Here's where it really gets really weird, right? If I do this one on this side, so you can see I can be right in there, right? This is how deep I can be inside the bounding box. That means I can detect a collision if I used axis align bounding box almost to there, right? Take a look. So I'm definitely not colliding on this side visually, but I am colliding on my rectangles are overlapping computationally, right? So I could use axis line bounding box as the first check for broad phase collision. Am I close enough that I'm going to have a collision? And then I can use narrow phase, a second round of collision detection, if I really want to get really specific, right? So I can check something else, like distance, the distance between the centers of my object, distance between here and here, right? And if the distance, the radius of my objects, if the distance between my objects is less than half the radius of each of the objects added together, right? That means they're inside of each other. Because if the radius means from the middle to the outside of the object, right? Some radius that I would define. Now, radius works great with the plane, but the problem with this object here, it's irregularly shaped, right? And again, this is just a problem I'm trying to show you, right? So let's draw a radius, some kind of circle, right? So here's a circle object, right? And let's just make it so you can see what the hell we're doing, but we'll keep the border here. And here's the circle. And let's say for a second, let me just lock down the bitmap for the cloud, which would be this one, right? And I'll lock down the other ones. I'll lock down the ocean, and I'll just have the plane. Here's the plane, right? And here's this thing here. So let me just put this thing. So you can see that the circle doesn't quite fit around this object, right? Doesn't quite fit, right? It might be in some ways just as bad as axis aligned bounding box, because remember, I'm calculating from the middle to the edge of my circle. Math, we're talking about again, the radius, right? From here to here. So if I draw that radius from here to here, line from the middle of my object to the circle, that's the radius, right? And I would do the same thing for the plane. Plane is a little easier because it's kind of squarish, but this is okay here, but what about down here? Again, I'm going to have that same issue where the radius of my object, right? And again, I can offset this thing a little bit to make it a little bit more realistic, because my bounding box on this object here, let's just see if I can select it. You can see the bounding box and my circle are differently shaped. Let's make my circle smaller, right? So I can change the radius. So we'll modify it. So we'll make it smaller. Now, the problem with this radius, I'm just trying to help you out so you can understand the challenges here. And the big challenge when it comes to creating a collision detection system, how do you collect it, detect collisions, right? So I'm going to go from the middle all the way to the right, okay? So you can see that there's a part of the cloud here from a radius perspective, right, that is outside of my circle, okay? How could I do this best of both worlds, right? I want to use some kind of box, right? And I want to use the radius, but this is going to move so fast, chances are, right, I'm not going to have a problem with this kind of game. Remember, every game is different. And what we've been showing you so far up until now is it's all tricks. There's no new objects coming down. I'm resetting everything, right? It looks like there's new objects, new clouds, and new islands, but actually there's no new islands and no new clouds. The same clouds we're using over and over again. Tricks, smoke and mirrors, whatever you want to call it. Most video games are like this, okay? However, here, I have to detect something. And I know that the clouds are coming from above me. For radius, heights of my objects, because it's coming from above. So I don't care about the sides so much. Work. In code, if I go back to the code for a second, right? And I want to go do this in my game controller code, right? I want to do something like this. I want to say that every update, right? Every update, I want to check to see if there's a collision between my cloud, as an example, and my plane, or my plane and my island. So I want to check for collisions. I want to check collision, right? Now, I can do it in a method. So I can call this, a method that says something like, we'll start off like this, avoid, right? Method that's called, we'll call it island and plane, or plane and island. So plane and island. I want to check my plane and island, right? Now I'm going to show you this is pretty inefficient. And what I'm going to do here is every update, right? When every tick of the frame, every frame, I'm going to call my plane and island. This is my plane and island collision check. I'm just going to call it plane and island for now. And if I did this, I could say something like this, right? If, remember, I have two things. In order for me to check my plane and island, I need a reference to my plane and island objects. I'm starting with island because it's easier, okay? Cloud, something else, right? But let's suppose what I know. I know that every object has a transform. And every object, every transform has a position related to it. That means every object has a position. I know exactly where the object is every frame. I know where it is. Can I not take the vector between one object and the other? Because really it's not vector that I'm making. The middle of my one object and the middle of my other object creates a vector, right, with magnitude and direction, okay? All I care about truly is the distance between these two things. And Unity helps us do this because if I look at the Unity scripting, so if I look at vector 2, right, because I'm only looking in 2 dimensions, right? I can do a couple things. I can calculate the distance, right? If I look at distance, it tells you I need a vector 2 and another vector 2. Yeah. And what I'm getting is, so I'll say vector 2 dot distance between A and B. I don't have to make this thing up, right? I can also do A minus B magnitude, same thing. But vector, the distance between one object and the other, Unity already has a function for that, to calculate the distance between two objects. The first thing I need to do. So I need to do this distance formula. Otherwise, I can make my own. And the distance formula that it uses is the Pythagorean formula, or the Euclidean distance, you should call it whatever you like, where c squared is equal to a squared plus b squared. And how would you find that out? If I go back to, if I wrote it on my own, it's all pixels, right? It's all pixels. So how many pixels this way, how many pixels that way, rise of a run, or the distance is actually the hypotenuse, right, which is c, and A and B are the horizontal and vertical axis, right? So I can say C then is equal to the square root of position 1 plus position 2 squared, each one of them squared. That's what it is. It's just the Pythagorean formula, right? But I'm using a square root, and every time I use a square root, it's heavy duty in terms of every frame. I'm calculating square root, every frame. It's heavy duty, right? I'll leave it like that for now, but there are ways of doing it where I don't have to check every frame. And I'm using distance calculations because it's easier than using a broad phase and narrow phase collision for this kind of thing, where I check the bounding box first and then do something else minor to get me closer to the thing. It's probably good enough just to use distance. Okay, so that's what I need to do here. So when I go back to my code, okay, if vector 2 dot distance, right, between one object and the other, right? So what I really want to find is the transform position, the position of two objects. But I have no reference right now to my plane or my island. I get a reference here for both of those objects. So I've got my cloud, might as well get my plane and my island. So I'm going to do that first. I'm going to say public game object, public game object island, right? Those are the three things I'm looking for. When I do this, I'm just going to comment this out because it's going to give me an error in a second if I don't do that. So I'm going to comment this out for now. If I do this and I go back to Unity, right, you can see that the game controller now asks for my plane and my island. And I can drag and drop references to my plane and my island into my controller like this. So I take my controller and drag my plane into my plane and my island into my island. In an island, right? Maybe I should say player and island. So if I wanted to make that change, it would wipe out the player if you made that change. So if I said player, by the way, this is only one way of detecting objects in the hierarchy. You can use another way of getting the object by find the object by name. Do that. We'll have to do it later. Yeah, so if I do that, and if I go back, you can see it wipes it out. So I'm just going to take the player and put it back. There we go. All right, so I got player, island, and cloud. And notice that these two objects here are multicolored objects, right? Whereas this object, the cloud object, is like a blue object. Blue means prefab. Multicolored means objects in the hierarchy. Okay? All right, so if I do this now, I have references to my player and my island. Well, guess what I can do? I can say, well, that if the vector distance, right, between my player, remember, I have to return a transform position. And it'll be like this, player.transform.position, right? If my distance between my player.transform and position and .transform, by the way, there's other ways of fixing this, dot position, right? If this distance, right? And by the way, you're going to see that there is an underline, is less than, right? Less than my player object dot height and my island object dot height combined, right? So player dot, can I say height? Is there a height object for my player? Player dot, there is no height, right? How about my renderer? Like, I got to think of what I can do, right? What do I have with my player object, right? So I can't really get the heights right now of just by using this. I know I can do this, but I need to compare the position with something else, the heights of my object. Okay. Let me just undo this for a second. I'm just gonna comment it out so we don't get an error. So I kind of do one of these. Okay. All right, so let's go back to the drawing board. Player, I got this. I've got my sprite renderer, right, or whatever. And I also have my player controller. Can I somehow figure out the height of my player based on my sprite? Can it read the sprite height, right? Now I know that there's a sprite renderer object, right? I know that there's that thing. And if I look at sprite render and Unity, again, I'm using the Unity scripting aid because if I say sprite renderer, the reason why I want to show you this is because sometimes we have some built-in things that we can use. Okay, well, oh look, we have sprite renderer.size. It says property to get set the size to render when sprite renderer.draw mode is set to sprite draw mode.9slice. Okay, not exactly what I'm looking for. A tag, a transform, a hide, a name, a bounds. Oh, the bounding volume of the renderer, read only. That might be something we can do. So bounding volume, material. These are all things that I can get from my sprite renderer, right? Take a look. I can compare tag, I can get components, I can send messages, I can get instances. And why am I doing this? Because why don't I know how big my sprite is. Why don't I just put in the number? I can say 65 or whatever. I know the number. Why don't I do that way? Because this way I can make a class. I'm looking to make a class in the future and compare any sprite. I don't care about the to figure out what it is individually, right? Because then I would be hard coding it again. What if tomorrow I have 10 different kinds of sprites, right? Right now I'm looking at 2 objects to collide. Eventually I want to make a general collision detection algorithm that can detect collision between any 2 sprites, right? But we start small first. We start between 2 things, figure them out, and then expand that method to make it more complex and more general. So I want to use either size or we know that there's this other thing called, not broadcast, what was it again? Bounding or bounds, the bounds. And if I click on bounds, this is the bounding volume. Now it says it returns, it's a type of bounds. It's interesting. It's a type, bounds, right? So here's a renderer. We get a component renderer. We're going to have to do this part right here. And we're going to say something like this. Well, I want to get the bounds center, right? Bounds center. So you can see that I can get a reference to the renderer of the actual sprite, right? And then I can get the center of the object. And maybe, look, I can probably get other things, extents, magnitude. I don't know what that is. That gives me the radius. So I can almost get the radius by using the bounds thing. I actually store it somewhere in here, right? So this might be a hint of what I can do. But notice that it inherits from the bounds class. If I click on bounds, here's all the things I can do. The center, the extent, the maximum point of the box. This is always equal to the center plus extents. And the minimum point of the box, right? So that's really cool. The minimum, maximum So this is another way using the renderer, a axis aligned bounding box. I can create that algorithm if I want to, right? And it'll be dynamic. It won't be fixed. Okay. Here's another one. How about what is Extense? So if I click on Extense, it's a vector3 object, right? And it says bounds Extense is a negative value for any access. This is always half of the size. This is what I'm looking for right here. So the extents of the box, which is always half the size. It's a vector3 object, okay? So why am I getting this information? Because I want to be able to detect how big my sprite is. That's what I'm looking to do, right? Because it's going to be my bounding box, if you will, or I want to use the distance and look at the bounding box to detect if I'm in that space, right? Now, the easier way, by the way, guys, is to use built-in colliders that are built into Unity. I'm not going to do that yet. We'll do that later. But I want you to understand the underpinning things that are here so you can understand what's happening, right? This is somewhat what they do. All right, well, if that's the case, I got some work to do, right? Because for me to find player gives me the game object, right? And I want to look at that get component because the game object itself has a renderer. And the renderer has bounds, right? That's what it is. Renderer, remember we talked about this? If I go back up the chain, right? Here's my renderer, here's bounds, right? Renderer bounds, right? Dot extents, right? That's what I want to look at. Renderer bounds extents. Here's my renderer, sprite renderer. And I want to get a reference to my renderer, right? And that's what I want to do. I want to get component renderer. And I want to align this for the player. So this is a lot of work. Let me show you how it's done. So these are public values, and I can make some private values, right? So we'll say, here's some private fields. Private fields or instance variables. I'm going to make them so that you can't see them. These are more like public fields that are exposed on the inspector, right? And inside the private fields, I want to create a couple things. I want to get a couple things. The transform of each of the objects, right? Or position, if you will. So if I say private transform, you can see that I don't have to go with a game object. I can actually go right down to a transform, right? Well, I need the player itself, the game object, because I'm not just looking for the transform. I'm looking for also the renderer for all the objects. So I want to get the transform of all the objects and the renderers for all the objects. So I'm going to say private transform, and I'll say player transform, right? The player transform, right? Now, inside my start method, I'm going to kind of define what that is in a second, right? Private transform the island transform, and private transform. Now, but again, there's different ways of doing this. I want to show you the hard-coded way of doing it, okay? And the cloud transform, okay? So I'm going to need the cloud transform later, okay? So player, island, and cloud, right? And I'm also going to need a private. Now, I need a component, right? And I can't, if I type renderer, right? Renderer is a class. I can say something like, I know that each of them have a renderer. So I can say that the, one I'll call the player renderer, right? And private renderer. I'm breaking them down because it makes it easier for me to code. Otherwise, I'm going to have this big, long piece. Like I'm going to say player.getComponent.renderer.bounds.extents. Like it's really, really long, right? And what I'm doing is I'm just making little like shortening things a little bit for myself, right? And this is my island renderer. And I'll do my cloud renderer for now. So I got all of them. Cloud renderer. And I want you to think about the render as the drawer, the object that draws the sprite. That's what it is. And the renderer contains the sprite, right? So these are the things I've done. Now, in my initialization, right now, I just set my list object and I instantiate my list. So just some comments. So here inside my object, what I'm doing is I'm create a list of clouds. That's what I'm doing here. And here, I'm actually going to set up my initialized game objects here. Now, you're going to see that there's a problem with what I'm doing, but I want you to think about this. I'm creating player transform, island transform, cloud transforms, all these things, right? All these things. And let's just go through this. I'm going to say, well, my this dot underscore player renderer, right? Let's do the player renderer first, is equal to player. So this dot player component. I'm searching for a component called renderer, right? So what this player.get component does is it looks at the player game object and looks for a component with the name renderer. And it's going to find the first component. So as an example, my player object, if I go back to Unity, if you look at my player object, it has this sprite renderer. It's a renderer, okay? So my sprite renderer is of type renderer, and what it's going to do is it's going to it has a series of properties or whatever, and my sprite renderer first, this thing first. So if I had more than one renderer, it would find the first one, okay? If I use game components instead of game component, it would give me a list of the same type of component. So if I had 5 renderers, it would give me a list of renderers, and I can go through that list. But here, I'm only looking for one, okay? Now, let's see if I can just get the component renderer, the player one working first to show you the complexity that I'm talking about here, all right? So without here, my plane and island, I'm just going to keep this commented out for now because I'm not completed yet. And I want to do something like this. I want to say I want to do a debug.log, and I want to print out the player or this dot underscore player renderer, right? And the player renderer has some options, right? My bounds, right? Here's my bounds for my player renderer. It's going to return. If you notice what bounds returns, right? My bounds objects, and I can't get a thing. My bounds dot extense is my extense, right? I'm looking to return that from my player, right? Every frame, it's going to return this. So I'm looking to see if I can get a number here. If it becomes undefined, something's wrong. So I'm looking at, this is the stuff I'm looking at. If I'm looking at bounds, if I look at extense, extense should return a vector3 object, right? A vector3 object. So, and maybe what I want is I want to make this go toString. So if I go, maybe I can do toString. I can return a string representation of my bounds. Okay, that's what I want to do. So let's try that and see if that works. Now, you see how long that is? If I didn't shift it to player render, it would be like this. Okay, that's how it would look. Player.getComponent renderer in brackets dot bounds dot extents dot toString. It would be like really, really long chain of stuff, right? I don't need that. By the way, there's easier ways, but I want to show you this first. Okay, let's run it and see what I get. So every frame, I should get a number. Yay! Look what I'm getting. 32.5. I'm going to stop it for a second. Let's look at the console. I'm getting 32.5, 32.5, and 0.1 in the Z axis. Why am I getting 0.1? Because it has a thickness. Every sprite is actually a plane, right, with a minimum amount of thickness in the 3 dimensions, right? It's just a plane that I'm getting. But 32.5, I'm getting the value that I want. 32.5 on the X and 32.5 on the y, right? Do I care about the y? Yes, because that's the one I care about, right? Up and down. The x, because I'm not going to, my plane is not going this way. It's going, my cloud is coming from above. My island's coming from above. It's not going this way. So all I care about is the y value, which is the height, half the height of my object. So this thing here, player renderer dot bounds dot extends dot, this whole thing, I don't care about this whole thing. I only care about, and I can look at x, y. I only care about the y attribute, right? This is just the y attribute. And this y attribute is half the height. That's all I care about, right? So if I do this again and I run it, you can see that I can get through a string of arguments half the height, which is 32.5. Okay, if I do the same thing, and now that I've got my player renderer, if I do the exact same thing and do this for the island renderer, player renderer, we're going to say underscore island renderer is equal to island.getComponent renderer, right? Same idea. And then I go down in here and I say, well, what's my island renderer? Can I do that for the island renderer? So see if I get this thing. So what I got 32.5 for my player on the y-axis. Let's see what I can get for my island. 31.5. Okay, so that's a little difference because my island is a little bit flatter, a little bit shorter in height than my player. Okay, so I got that. Now let's do the same thing, right, from my cloud object, because all the clouds are going to be the same size, right? I'm not rotating them or anything like that. That's why I'm not rotating them right now. That's a whole other thing to figure out, right? But let's suppose that my cloud object, my cloud renderer, I'll do the same thing. So up on the top here, I'll define it. And plane, island, and clouds, we'll say cloud renderer, right, is equal to cloud.getComponent renderer. And if I want to test this out, I can see that the cloud renderer.balance.extents.y is going to be something else other than 31.5 and 32.5. Let's see what that is. 89 peoples. 89. It's 89. Half the height of the cloud is 89. All right, that's pretty good, right? Am I rotating them? I am rotating them. Woo-hoo. That's not good. How did I do that? Did I take those things out? I thought I had. Maybe I forgot them in. Yeah, I left them in. Let's not take the, let's take those crazy things out for now, because otherwise we're going to have some weird effects of this. I don't want to do this right now. Actually, I'll just comment them out because maybe we'll use these. I was kind of showing the class during break how you can change stuff around for people who are watching remote. Okay. So now that I have that, so that's one thing I can do with getting components, because I wanted to show you that so you understand how I can get specific components from an object. You're going to need to do that at some point. All right, so that's what I did here with this one. But why about these transforms? Why am I getting these transforms objects? Because I can also define them. I'm just going to define them up here. So what I can do is I can say this that underscore player transform. The player dot transform. Right? I could also do something like this. I can say player dot get component, right, transform. Both of these are correct, but I'd like to use not get type, get component transform. And the reason why I like to use this form as opposed to player dot transform is because it actually looks at the component, right? It actually gets a component. Now I can do it either way, but I prefer this form. So I'm going to do the same thing for the other one. So I'm going to say player transform. This will be the island transform. Island transform. And this will be the cloud transform. And it'll be island cloud. And why do I need to transform? Is because it'll make this calculation down here way easy. Look at this, player.transform.position, right? Too long. I can just go player transform.position. right? Instead of player.transform.position. Okay, now I'm ready to try this out. I have the heights. I can do that, and I can do it pretty simple. This cloud renderer.bounds.extents.y is kind of like the height of my cloud and the height of my player. I don't want to do this all the time. I could create, I'm going to need my renderer here, right? I'm going to need my renderer, but I'm also going to create a couple of other variables just because I feel like it. You don't have to. And I want you to think about, how do I simplify all this? Because it looks like identical, right? Again, it's crying for a class. That's what it's doing. It's saying, please don't do this. You're duplicating. Is there no way you can use a class to do all this work? There is a way. We're going to get there later. First, simple steps. Brute force. Let's make it work. And then afterwards, we'll optimize. All right. So I want to do something like this. I want to say that in my private field, I want to create a couple more private fields. I want to say that the now these are going to be floating point values, right? So I'm going to say we're going to call player height. We're not going to call them half height. We're just going to say player height. They're really half heights, but we're going to make it easy. So player height, right? And we're going to say the same thing with island heights. So we're going to say island heights and cloud heights. Island height and cloud height. Okay, so I have player height, island height, cloud height, lots of variables, really inefficient. That's okay. Down in here, what I'm going to say in my initialization, I'm only going to do this once. I'm going to say this dot underscore player height is equal to this dot underscore player renderer, right? Dot bounds dot extents dot y. Is it, instead of me typing all of this every single time, it's type player height, right? Because that's what it is. I'm just making this whole line here. I'm reading what what's in the player renderer, and I'm attaching it to a height. I want to think about this pattern as making one object. So I read the object, whatever object it is, right? I don't care which object it is, right? In my object array, and then I want to read the height. So I can do this one time for each of the objects. That's what I want to do. Cool. Now, I'm not doing that right now. I'm just making a brute force summation of everything. So here, I'm going to do the island height. And here, I want to do the cloud height. It's good repetition, too, for you guys. This, I'm going to use the island renderer. And this one is going to be the cloud renderer. Now that I have all these in place, this is just placeholder. This is just making my life easier. That's what this is. All this stuff. Okay, so although it looks hard, but now here in this little line, I've got all the information I need to see if I got a collision. So I want to do player and island, and I want to say if vector2 distance, instead of player dot transform position, I can say that this dot player transform dot position, right? So I know what it is, right? Player transform dot position, and the other one is island transform dot position. This, I'm choosing this dot island transform dot position. Not really saving anything here. Is less than. Just put this on the other line so you can read it. Is less than. So this whole thing is the distance formula. This distance formula is less than the combination of this dot underscore player height and this dot underscore island height. That's what I want to say. If that's true, then I have a collision. I'm going to say debug.log, I'll say in brackets something like, oops, wow, that was weird. Debug.log, I'll say collision, right? All I'm doing is breaking it down so you guys can see it. So I'm basically what I'm saying is, hey, I'm using vector2 distance method to calculate the distance between the middle of my objects. If the distance between the two objects is less than half the height of the objects, right, then chances are I have a collision. That's what I'm doing here. Now, you're going to really be mad at me later when you see how much easier it is to use the built-in Unity collision system, right? But I don't want to use rigid bodies, right? I don't want to use rigid bodies here at all. I'm avoiding rigid body use altogether, right? Because it's another component. And I don't need to use it really because I'm just doing 2D. But I'm making it a little difficult for me. I'm kind of, what I'm doing here is reinventing the wheel a little bit, right? But I want to show you how collisions kind of work from a distance perspective. And let's see if this works. So save it. I'm only checking plane and island. And so if I cross over the island, then I have a collision, see? And I have a collision. And I have a collision. Okay, let's stop. Let's see how many collisions I got. Whew! How come I got so many collisions? Huh? No. These are all collisions over the island. This is good stuff. Not because I'm bad at the game. I only passed over the island 3 times, but I got a bunch of collisions. Why is that? I want you to think about this now. Okay, I'm going to look at Winston. Winston, why do I get so many collisions? Nudge him. Winston. Why am I getting so many collisions, right? But I'm only passing over the island 3 times. Very good. How constant? How consistently am I checking? How often? Well, no, every 16 milliseconds, every frame. Every frame, I'm checking to see if I'm colliding, right? Well, look, if I pass over, let's go back to fireworks for a second. So here's my my object, and now I'm using some other object instead of the island. But let me just see this for a second. I'm just going to get rid of this stuff. So I want you to tell me. So this is 1 frame. I'm moving at 5 pixels per frame. Yes. Am I colliding now? Yes. Am I colliding now? Yes. Am I colliding now? Yes. And so what's happened is I'm going to get 3-4 collisions because my plane is passing over my island, right? And I don't want that. I want to know that I've only collided when I've already collided with my island. Flag that tells me that I'm colliding. How do I make this whole thing simpler, right? Because it's driving me crazy. I got to check renderers. I got to check, collision bounds. I got to do all this stuff. I'm not going to use Unity stuff yet. I'll do that later on, maybe next week, right? So, decision from a design perspective. How am I going to design stuff? Should I put the collision detection and all this stuff? I'm doing a lot of stuff here on the game controller. Is there not something I can do in each of the objects to help me? And the answer is I can, right? I can keep track. Each object can detect its own size, right? And report it as a height, right? Each object can also keep track of is it colliding and report it as a Boolean, right? And if that's true, right, then I can check to see if that object is colliding. And if it is, don't check anymore until it's not colliding anymore. When it stops colliding, then make it false, right? And then only check when it's when the is colliding method or Boolean is false, right? So I only show 1 collision every time I hit an object, not multiple collisions. Because if I do sounds later on, which I'm going to do, right? Imagine if every time I collide, it makes a sound. It'll go until I come out of the object. It'll be wrong. Instead of bing, it won't do bing. It would go bing because I'm going to go through the object every frame, right? Which is wrong. Right? You like that? Right? So this is wrong, right? This is a nice idea. I understand how this works, right? So can I not do it? So let's start with my player controller. My player controller, it's all about my player, right? I know I have some public properties, my left boundary and my right boundary. But could I not declare the width of my object as a floating point value and then figure it out? or my height. So let's talk about two things that I need. I only need height right now. All right, so public, actually I'll make it private. We'll call them private fields. Doesn't matter where you put them. We'll organize our stuff later on when we do another project. So here's my private fields. And inside there, I want to make a private height, floating point height field, right? Here's my height. And instead of doing all this crazy ass work, right? What I want to do is inside my start method, which is nice and empty, for me, right? So I'm going to do something like this. I'm going to say, did I make it private? Sorry, it's got to be public. And also, I may want to think about not showing this on the inspector, my height. But let's suppose I leave it as is, right? My height. Well, I want to make it like this. I want to say that this dot height, right? This dot height is equal to, and again, this is where I would do this. So game object dot get component, right? And then inside my component, I would call for the renderer. I'll do it all in one, right? My renderer dot bounds dot extents dot y, right? And that will give me the height of my object. Yeah, one time, right? As opposed to me having to calculate it in my game controller, it's being calculated for me by the object itself, right? And this is really key, guys. Once I have this information, I don't have to make references to all this extra extraneous stuff, right? The objects themselves should tell me how high they are, not me trying to figure it out from my game controller. Let's take the same pattern and putting it, this I can use the exact same pattern, look, without specifying player, and put it inside my, here's my island controller, whoop, and I just have to put in a height, a public height. So we'll say public fields, say public height, floating point height. Okay, notice that I have, again, duplication. If I was going to make my specialized game object class, then I would add my height to each of the objects. Okay, there he is. So I've got my height, it's public value. And let's do the same thing for my cloud. So before start, I do one of these. Oops, undo. Meant here. And I just put in a private field. Oh, sorry, public field that is public height, floating point height. Now, again, there's many ways of doing this thing. But the reason I'm doing it this way is it gives me the height of my object. Okay, cool. The other thing I talked about, I'm going to go back to my ocean. Sorry, my island and my player. The other thing I talked about is colliding, right? It's not my player that I care about. It's my island and my cloud that are colliding. They're already in collision state. Not my player is always colliding, right? But I want my island and my ocean, right, to be in collision. That means I can collide more than once with different objects. If I made it on my player, then what happens if I get 3 clouds coming at me at the same time? I can only register a collision once, and I want to be able to register multiple collisions. So I wouldn't do it that way. I would do it this way. I would say public Boolean, right, is colliding, right? That would be inside there. And inside my start method, I would initialize that. So this dot underscore is colliding, or did I call it is colliding? Is colliding, I'm bad, is equal to false. So I would initialize it at false, because let's face it, I don't want to start it off as colliding. Okay, so same thing with my island. So I'll go over here, and I need to make a public bool. I just call it is colliding. Now, I'm not calling it underscore because it's public, right? And same thing with my cloud. Okay. Now, why did I do all this work? Because I can save myself from doing all of this work, right? I'm showing you how to, I'm starting to optimize a little, very little, right? And I don't have to do any of this stuff. That means I don't need to know player bounds. I don't need my renderer. So all this stuff here, all this code here, gone. Right? I don't need my, well, transform, I'll leave my transform because I'm going to need it later on. But can I think about ways of getting my transform in a different way? And there is a way. Well, let's get rid of all this stuff. So all these extra variables, other than my transform, I'll leave my transform alone. I can get rid of. Now my game controller goes back to normal, right? But I need to change this stuff around. And how do I do that? Well, this stays the same. Player transform position and island transform position. But instead of player height, this dot underscore player height, which I don't have, I can just simply do this dot player height. Now hold on a second. How come I'm not getting my height here? And you tell me why I'm going to get my height here. It will work. I'll show you, but I'll tell you why it's giving me an error. Right. So, and this dot island dot height. Can you tell me why I'm not getting code hinting and I'm getting these errors? Why would I get errors? I already made them public. Look, so my island, it's public, and on my player, it's public, but I can't see it in my game controller. Why? Anybody have an idea? Let's take a look. Some hints. What am I declaring my player and my island as? Huh? Game object. Does game object by default have a height? No, right? So because game object doesn't have a height, I have to cast my player as a player object. That's another issue. How the hell do I do that? How do I cast my player as a player object, right? And my island as an island object, and my cloud as a cloud object. How do I do that, right? So that's an issue. That's a real issue because I don't have those kind of things in here. This work, I want to get my height as an example. I want to get these two things, right? And this is really challenging to do, right? Because I want to get heights, but I don't have it. So how do I do it? Okay. What if? Is there a way somehow to do it in Unity on the Unity inspector? Remember, here's my game controller, and I've got my cloud number, and I got player, island, and cloud. Could I ask for other things in here, like the player height and the island height and the cloud height? Is there something I can do there that gives me that? Is there a component that I can search for here that is a thing that I can put in here that I can automatically drag and drop? Will it detect that? I'll tell you that there's not an easy way. Okay, I can tell you that part of my player, I can find my player and my island, right? Instead of using game object here, right? I could find my player and my island by using something called find. So I can do something like, well, my player, sure, it's a game object, right? But inside when I start, instead of doing player is this public thing that I'm getting, what I want to do is I can cast my player as something else. And the only way I can do that is I have to cast it as the component itself, the script component itself. So how do I do that? First of all, I gotta say that I want to get access to the script. That's what I want to get access to, right? Because the script themselves have those options. The player script or the player controller is what I'm looking for, right? Not the actual player object necessarily. The player object is neat, but I'm not really using it anywhere in here, right? Other than for the cloud, right? But my player itself, I also have a script component. So I can use this player.get component, and then it'll be called player controller. All right? Just bear with me. I know this is a mess, but I want you to also understand this lesson is all about understanding how things link together in code. And how do I access stuff in code, right? Otherwise than dragging and dropping. because we're not going to get to this. Once I start layering colliders on, you're going to forget about this whole thing, right? And then when you have a problem, you won't be able to solve your problem. Huh? Yeah, I know, it's crazy. I'm sorry. I know I'm kind of building things up with you guys, but there's no other way, right? So again, if you think about the player is a game object, right? But is there a way reference to the player object instead of a game object, but as something else? So cloud, that's neat. Can I do it without breaking my code? Well, I'm asking for game objects, but what if I ask for player controller, island controller, and cloud controller? Okay. So let's say my game object, instead of game objects, I'm saying, you know what? My player is not actually my player, it's my player controller. And my island is not actually a game object, it's a island controller. And my cloud, this is going to mess me up, it's not a game object, it's actually a cloud controller. The script. Yeah, the script is being brought over inside, right? Now, once I do that, right? Once I do that, then this becomes different. Okay, we're going to get to that in a second. Okay, this definitely is different because cloud is now a script, right? And cloud is not the object. What I really mean is that cloud, we need to get the game component, game object belonging to the cloud. Cloud meaning that think about this, the script itself. So I'm looking at the script, the game controller, the cloud controller script, and now I want to point to the game object that the script is attached to. That's what that does. Cloud.game object means take a look at the cloud script and what's the game object that it belongs to. That's one. Now I can do that. So I fixed that problem. Now look at how I'm getting height and height. I'm getting these two things, no problem. Now here's something. How about this player transform position? Can I still do this? Player.getComponent transform. Player is the player controller, and I can get the component, the transform component, connected to the player object, right? Now you might say, well, hold on a second, Tom. You said that this is the script now. How can I get the transform connected to the script? Wouldn't it be player.gameObject.getComponent? That's what I did down here. Object. Wouldn't it be this? Yes, it would be this. It would be this, right? But let's suppose that you didn't have to go there. Let's suppose you can just shorten it to do this. Is that good enough, right? So all I care about right now is that I can get the height and I can check for collisions without all that code. If I can get collision there, I'm not checking for if it's only one collision right now. I'm not setting it, I'm not doing that special code. Let's see if I can just make it work. Okay, so let's run it without any errors. So I'm running, I got a null reference exception. All right, and let's see what that reference exception is. It says object reference not set to an instance of an object. Game controller.start on line 24, right? So if I go in there on line 24, exactly what we said, it doesn't know what this is, this player component transform. Well, there's a reason for that, two reasons. One is because I've changed these things now, I got to reattach them. So here's my player. I got to drag my player because I've changed them from game objects to scripts. Here's my player. Here's my island, right? And here's my here's my, put this back to where it was, my cloud. Oh, my cloud, right? So I got player, island, and cloud. They're all controllers. Let's see if that fixes the problem. All right, so I have to reattach those. And okay, we don't care about the things there. And here's my island, and I'm firing over it, and collision. I'm good, right? Collision. So now I should only get two. I should only have two collisions, but I got a bunch of these ones because I passed over. Let's fix that problem now. So this worked as long as I have a reference to the objects. Oops. I'm good to go here. I've narrowed down my distance, my collision detection, right, to this smaller line, which is good. I don't have to use all that extra code, and I can do that by passing in a reference to the player controller script as opposed to the game object itself, right? Which is a little smarter, actually. Okay. Okay, well, if that's true, if this is true, and I can hold all this information, right? Now I want to check if I'm colliding. So I don't want to do this collision detection thing unless I'm not colliding. So I'm going to say this. I'm going to say, well, if my island, this dot island, this island dot is colliding, right? That means it is colliding, right? If not, this island is colliding. It's not colliding, right? Only then do I want to check to see this is true, right? So I want to take this in there and put it inside here. Why? I'm checking to see if the island is colliding. If my island is already in collision, I'm already colliding with my island, don't register another collision. However, if I'm not, if this is not true, right, then register a collision and set the collision to set this collision to true. So I'm going to say, okay, I'm colliding, and I'll say this dot island dot is colliding is equal to true. I'm changing it to true because now I'm colliding already. I set a collision. I'm registering the collision in the Boolean. It's like a flag that I'm setting saying, hey, my island is colliding right now. Okay, and then what if this is not true? What if my distance, I'm not colliding. I'm colliding. I'm colliding. I'm colliding. Right? That's what's happening here. Think about this. Should I do this up here to check the collision here, or should I check it down here? What would you rather do? Would you do the if statement on the outside, or would you do the if statement on the inside? Right? So check to see if I'm in range. If I am, register a collision, but only if I'm colliding. Here, let's undo this change. What I really meant to do. Oh, let's change. Sorry, let me keep that change. Is true. What I really meant to do is put this one, this check on the inside. So I'm going to say something like this. I'm going to say, well, only if I'm not colliding, do this. Right? Okay, so only if I'm not colliding, then do this. So say if the island is not colliding, then register a collision and then change my collision to true. Okay, cool. However, if I'm not colliding anymore, then I want to say that else I got to rearrange this. I got to reformat this for you guys. Else this dot island, I'm not colliding anymore. That is colliding is back to false, right? Because I'm not colliding anymore. If the distance, if this doesn't pass this check, the distance and the height check, right? Then I'm not colliding anymore, right? So then I can reset my island back to what it was. Yes. If you didn't put the else, then would it just stay colliding? Forever. Let's see if I can format this. Does it have a format? No. I gotta do it manually. Sorry, it's just my version of Visual Studio. Okay, so this should work. So this should be one collision only. Let's see. So that means if I pass over the island twice, I should only get two collisions now. Let's try this out. So go back and I run it. I pass over the island once, collision. I pass over the island twice, collision. And I should only have two collisions. Let's see if that's true. 1, 2. Right? Now I know that my collision is working. Island, right? Wouldn't it be nice if it can work for any two objects? Uh-oh. How the heck am I going to do that? I'm only checking between island and plane and island, right? Well, it shouldn't matter, right? I should create, let me make another function. This is what it should look like. Void, right? Check collision. And I want to check collision between my plane and another game object. It's always my plane and another game object, right? So it's the other game object that I'm worried about. but it's either going to be my player, my island, or my cloud. And these two things, right, are different. They're different, but they're a type of mono behavior. Both of those two things are a type of mono behavior, right? However, if I do go game object, if I look at game objects, I can use the game object that's attached to my player, my script to check. So I can say something like this. Check collision with a game object. And that game object that I'm going to make is going to be called other, whatever that other game object is, right? And then I can put the same thing in here. Instead of specifying island, right? Specify, I can take this script, the same exact script, I'm going to cut it, copy it. I'm going to put it in here. And instead of island, I'm going to use other for the for this thing here. So I'm going to say copy, right? And I'm going to put in other instead of this. But here's the problem, right? I'm checking to see before I go there, right? I'm checking to see that which one is colliding. And I also want to check that is colliding, the is colliding part itself, right? Notice is going to work, right? So I need to cast my other, depends on what it is, to the name, to the type, right? So before I continue, because this is not going to work, I need to do something like this. I got to say something like, well, if other dot name, the name of my other object, right? If other dot name is equal to island, I got to check for island, right? Then do something, right? I want to say that other, I want to cast it, right? As other as island controller. I want to cast my island as an other controller, as my island controller, right? Now it gives me a bit of an issue. It says, cannot convert type Unity game engine object to island controller via reference conversion, boxing conversion, unboxing conversion, wrapping conversion, or null type conversion. I want to make a reference to it, but I want to kind of say that this controller, right, is what it is. I want to kind of cast it as a controller, right? Because otherwise I won't have is colliding, because is colliding is a game object thing, not an island thing. So you see what I'm saying? I have to get a reference to this as a controller, not that. Now I could do this. I can try it as an island controller, or I can say that other, trying to figure it out, this game object other is equal to island controller, right? I could do that. But then I'm going to have the same problem. I'm trying to say that, well, this other object is equal to thing. Well, what if it was another object, not game object? Can I do something like object? Is that possible, right? Some kind of generic object. I want to cast it as something else, right? So it doesn't have to be a game object here that I'm checking for. It's going to be a type of script, a type of script. And if I look back, when I look at the script, game controller script, can it be that I'm looking for a script type? Is there some kind of scriptable object or Unity script, right? Is that okay? Namespace Unity script, but it's got to be some kind of scriptable object. Yes. What do you recommend? Which is what?
Other dot get component.
Dot?
Yeah,
but then I can't, if only if the other name is, only if it's other, right? So I'm trying to make it so that I'm checking the object, right? But really, I don't have to do this. So to get to your point, I'm going to keep game object as other, right? other.name is equal to island, then what I can do is I can create variables, right? I can create variables where I have a variable that comes into place in here, but the other is the game object, right? So I want to kind of, I'm going backwards now. I'm kind of saying, well, if my game object is called island, then I want my other to be equal to this island controller object, the island controller script, right? It's almost like what you said, Eddie. It's other, which equals other dot game object, right? Dot get component. Sorry, other dot game component or get component, and in square brackets, I can put in some kind of script or something like the scriptable component. I can't put island component because once I put island controller in there, right, then the problem with this is that other, because other is a game object and island controller is a, right, mono behavior. Maybe mono behavior is what this has to be, right? Mono behavior. That would work. No, mono behavior works. Yeah, mono behavior is the script type, right? So I want to pass in a scripting type, and then I can say, well, if other is island, as an example, then other is equal to island controller. Or now that I did that, I can say that other is equal to other as island controller. Okay? And now that I've cast it, I can do something like this. I can say, well, and I go else if. Let's do the else if first. Else if other.name is equal to cloud, right? Because it could be a cloud. Then other is equal to cloud controller. Right? So one of the two things. Well, either one, if I take other now and go in here and put is colliding instead of other, I should be able to do this piece, right? If I'm casting it as one or the other, but I'm having a bit of a problem, right? Because mono behavior doesn't understand about this, right? So can someone figure out what I can do instead of doing this up here? I could surround my statement with these statements here, right? And I could make this a single statement, right? Using a ternary operator, okay? So how can I convert this into a single statement? So I've got 1, 2, 3, 4, 5. So I can see the one or the other, right? It looks like this. Other. And if other.name, right, is equal to island, right? If other.name is equal to island, right? Then other as island controller. Else other as cloud controller. So what am I doing here? I'm assigning this to something else. Now, the reason why this isn't working is because there is no implicit conversion between island controller and cloud controller. Okay, I'm going to do Eddie's way. Is equal to other get component island controller. I think this may work. I'm trying to figure this out on one line here, as opposed to, I'm kind of going into the weeds too, which is bad. Other get components cloud controller. Oops. Cloud controller. I want to do one of these, and I want to do one of those. And that doesn't solve it because it's the same issue, right? Because other cannot be explicitly typed as get component, island controller. Or just say that it is an island. Instead of that one, it just is an island controller. Island controller. Island controller or a cloud controller. Because now we're going to run into the weeds. I don't care about what it is. I can just say it is what it is. Because I have a reference to those two things. Cloud controller. Nope. The same thing. Implicit conversion. I got to explicitly convert. Instead of island is equal to island as. Oh, that won't do it. So it won't work this way. I have other. I want to cast it as one or the other. Well, it's just to check if the other is not colliding. That's what I want to check, to see if the other is not colliding. And that I can't get that because mono behavior is, this is where I go back to that class thing, guys, right? I have my non-specialized class called island and cloud player. But if island and cloud were of type 2D player or whatever, I'm just making one up, right? Then I could check to see because it'd be both the same type. But because player controller and game, the other island controller are separate, I'm having an issue detecting if it's colliding. If I'm going to make one collider. Again, I'm not using the built-in Unity colliders here, right? So that's why I'm complicating my life and yours, right? I'm trying to do it on purpose, right?
I think you can always create simple interface for island controller. Just build abstract method.
Yes, I could, but then my island controller, I could create an interface. That's something I could do. Thank you, Eddie. So you're saying, that's a nice idea, actually. So instead of making my life difficult, yeah, instead of overcomplicating, but that interface that you're talking about at a application level, I have to serialize that, system serializable. Let's try that, just because you said it. And I'll put it inside the game controller itself, right? So when the game controller is instantiated, it'll have this interface. So we'll say, let's just see if this works. System serializable. You're talking about a public interface that we'll call we'll call 2D player. 2D player controller. How about custom controller? We bet something that's mine, right? And in my custom interface, I could define two public properties. One that is a type of a float, is a height, right? And I also can define a, why is this giving me an issue? Can't contain fields. Means it's got to be properties. So it could be, it would have to be a property. Yeah, but it's, yeah, it has to be a field. It has to be a get set. Yeah, because it's a, why is that not working now? JHT. Oh. Yes, I could do that. And a bool, which is colliding with a getter setter, built-in getter setter. Yeah, that would be the way to do it. Okay, now system serializable says attribute system is not valid on the declaration type. It is only valid on the class struct enum delegate declarations. So that's my issue. right? So that's a nice idea, but doesn't work here, right? At least not for that. Maybe there's something else that I can make for interfaces. And I'm running out of time. I'm timing out here, but if I wanted to say interfaces, Unity 3D, that's hopefully not talking about interfaces like user interfaces. Here it is, public. Where do I store this interface? I know how to make an interface, but where do I store it? It has to be somewhere. And I'm wondering if it's automatically. Well, you know what? It really depends on Unity, right? So if I don't make this like this, then this would suffice. If this suffice, let me say I custom controller. We'll just call it I for interface. If that's true, so we'll call it I custom controller, and then we'll make the island and not only inherit from mono behavior, but also I custom controller, right? And the reason why it's not adhering, because these have to be get set. I made them capitals. And these are get sets. Sorry, I'll fix this in a second. This is that one. And it's colliding with capital I. I'm going to fix this whole problem now in a second. Which is get sets. Don't worry, I'll put this code on up online in a second. Right? And let's see, the cloud controller script have to be the same because those will have to inherit from I custom controller. And the same thing goes here with height and is colliding, which are now properties, which is good because we don't care to see them on the inspector anyway. Let's see if your thinking is correct, Eddie. I like your thinking. I hope you're right because that'll solve the problem for us. It just says that I'm not inheriting properly. Why? Do I have the same thing over here in my island controller? Yep. Does not implement interface member custom controller is calling. That should be, that's why it's not doing it. Is colliding. Now we shouldn't have a problem with those two things. Okay, so that it does the interface members is height and is colliding, and that's what does these things. And now when I go back to my game controller, I can check. Let's just comment this code out here because I'm not going to use this plane and island anymore. Right? Sorry. And now instead of mono behavior, I can put in the special one that I want, which is I custom controller, which is another. And if there, I can check to see if it's equal to island controller or thing. I don't have to check for the name anymore. If it's equal to island controller, I can check for that. Right? I don't even need to do that. I can just say that, sorry. Yeah, I don't even need to do this check. But here, I can say that other, I'll see, A is colliding with a capital I. Is colliding with a capital I. That should work now. And is colliding with the heights, because that's island heights. And then the else. What was that? Oh, player height. I forgot to do that. Sorry, I did one more thing. Which one? Oh no, player height. Well, no, I have to do the same thing with. Oh yeah, no, I don't have to because I'm not making it of type custom controller. I can leave that as the lowercase one because that does exist. So instead of island height, it's going to be other heights. This could be island or cloud, right? Makes sense. So now instead of island transform deposition, I want other dot game object dot transform deposition. A little bit more complex, but other dots. I can't go to game object anymore. I can't get the game object from it. That's another problem. Hey, you know, we're halfway there. We're almost there with this stuff, right? But I can check. I can check if my other type is if other if get type. I think it's get type other, right, is equal to island controller. Let's see if I can do this. Island controller. Why isn't it giving me this? Get type. No overload method for method get type takes one argument. Guys, I did this before and it was so easy, and now it's not easy anymore. You did? You overcomplicated it? I know. I'm thinking of a way of doing it very easily to fix it within 5 minutes. So we only have 5 minutes left, right? I'm just gonna make it. All I wanted to make is a generic collision detection system. That's all I want to make, right? All right. So yeah, because I can't get the position. Huh? Get type. No. Yeah, use the collider from Unity. That's the easy way. No, I don't want to use the collider from Unity. I want to make my own, right? It's not wrong. It's just if other dot get type, does it take an argument, is equal to, I think, island controller. Put that in? Oh, no. I want to do that. Is a type which is not valid in the given context because island controller is a Okay, here's something I could do. Here's something that'll fix it, Eddie. This is just for you, right? Since you put this in. We know that we have height and is colliding. We could set up a name, right? And then we can check the position given the name. So because I know that I can't compare types right now because the way I can do it, I can set the name, right? So I could say name would be a string type name, which is going to be a getter setter. Bear with me. All right, so this is another way to do it. So I have the name of the object, the height, and the is colliding option. And inside my island controller, I just have to put the name, so public name. Wait. Let me just finish this thought, and then we'll go into the easier part later. Because otherwise, we're not going to finish, and I only have 5 minutes. Then we can think about how we can fix this easier later. Because I'm going to get rid of all this next week when I do Unity colliders, right? But I wanted to show you how this works. Okay. All right. So public height is colliding name. I had all these plans to do the interface too, but I didn't expect to get into this part. And then my get controller, once I have the name, I can check for that, but I have to set the name somehow. So I'll say that in my start function, I'll say that this dot name is equal to, we'll set it because this is the island. We'll set it there. I won't even bother trying to read it. That'll be another mess. This dot name is equal to cloud. Now that I've got those, I can compare, I have access to it directly, right? So because I've made the interface, then I should be able to go in here and check to see if it's a cloud or island, right? And if it is, I can create a new temporary game object, right? Where I can get the transform position from the island, like this. Then instead of other get type, I can say if other name, I have that, is equal to island. That registers for sure because I've already created that object. I'm just not thinking properly. Then, and I can create a variable up here called game objects, right? Other game objects, right? Then other game object is equal to island controller, or island, sorry, island dot game object. Okay. Else, other game object must be a cloud for now, cloud dot game object. And if that's true, then I'll say other. This is a real hack. Other game object dot position. There we go. Done. That'll work. Other game object dot transform dot position. Dot transform. A little long, but it would work. So that will do it. So now it should detect collisions with islands as well as clouds. This part because it's still looking for islands, and that's incorrect. Just search for clouds too. Hey, wow, that was easy. Let's just make this. Let's see, now let's test it. That's a nice idea, but we don't even know if it works. And plain and island does not exist. Yeah, because of course I left that script in, and I didn't change the script back to. We're almost done, guys. Give me 1 minute more. Check collisions. So check collision. Collision. And I got to pass in a reference to my islands. And I got to pass, I also got to do a check collision separately for my cloud. Right, so I would check for each cloud. Now this is for one cloud, but I want to check for each cloud. So I would do for each cloud, lowercase. Otherwise I'm going to have a problem. In clouds, I think I made clouds a clouds. Clouds lowercase. Make clouds lowercase. Why did I do that, Tom? For each cloud in clouds lowercase, this dot clouds, right? Then check collision cloud. So I want to check for each of the clouds. I want to check to see if there's a collision and pass in this. Cloud controller. Oh, sorry. It's the cloud. Hold on. Almost there. Another complication. A cloud is a game object of type clouds, right? And I want to get the cloud controller component of this one. So it'd be the, when it does this, cloud get components. Cloud controller. Right? It's a matter of understanding how things all plan to link together. Okay, we have some kind of code that might work. Okay, so let's see. So not detecting collision with clouds, but I am detecting collision with my, I did detect collision with islands, but my clouds, I'm not detecting collision with the clouds. Each individual cloud, for each cloud in this in the clouds, I want to get the specific cloud and check to see if it's colliding. Well, guys, we'll leave it there. I know it's very close, but the idea is that it's a generic. I'm trying to make a generic collision detection system. I could have made it easy by duplicating. I don't have a generic class right now that talks about custom class. But the idea here is that when you detect collisions this way, once you know you can detect collisions with the clouds and the islands, you can start using a scoring system. That's the whole idea here. I'm going to push this to GitHub so you see what I've done. And next week, what we'll do is we'll use generic Unity collision detection, right? And show you how easy that is compared to this. That was the whole point of this whole thing, right? But it's not that difficult. The reason why Unity exists with the collision system exists with Unity is because of this problem. Okay, and other reasons. All right, so let's end it up there. Thank you for listening. Thank you for hanging in there. And next week we'll fix this this detection off. Okay, thanks.